All right, I think I'm recording here. So we're going to give this a try. This is the auto device commissioning with Experion 500 and greater that we're going to test today. I've set up my system here to try to mimic a real life startup and commissioning scenario where here on the left hand screen is my Experion server, and I'll go ahead and start from scratch. So with Experion 500 and better, we have a project engineering section that we've added here to help or make commissioning easy or easier. I've developed a test here that's embedded in my Experion server. Okay, I'll show you the workbook. It's going to open up Excel. Okay, so here's my test procedure. Okay, results. And in a minute, I'll show you the as left report after we execute the loop check test. Okay. But here to my left, I have my control strategies. I have my Universal I/O 2 module. I have PC800-213 with a DACA block. So I built it according to my workbook flow, and I'll show you that here in a second. So here it is here. Here's my pressure transmitter. It's PT800-213 tied into a DACA block, that acquisition block, 0 to 20 pounds. Okay. So here to my right, which is my monitoring side, as you can see, I have nothing loaded here, only on the project side. Okay. Here to the right is an Experion Flex station that I'm using as my engineering commissioning station, as you will, or maintenance PC, where I have the PI800-213 pressure indicator. This is the instrument that I'm expecting to come in. I have a camera directly on the instrument so you can see the manipulation and the interrogation of the instrument from Experion. So in Experion, there is a service that runs. It's a HART service that initiates the loop test, the read and the write. So it writes 0 to 100%, and the instrument writes back to Experion saying, yes, I have achieved the 0 to 100%, which in my case is 0 to 20 pounds, 0 being my 4 and 20 being my 20 milliamps. Okay, so I think we should go ahead and just give this a shot. I'm going to go ahead and execute my loop test here. So automatically what it does, it interrogates the card. It's a 32 channel UIO2 version 2 card, Universal I/O version 2. And it did find my PT800. This is what I'm expecting on my channel name is PT800 on channel 16. So if I go interrogate, Experion is going to go into the UIO2 module and search for the instruments attached to the channels. Okay, so it turns it on, as you can see here to the right. It did turn the instrument on long enough to interrogate its HART properties. Okay, so there we go, it's on. So right now that service that's running, that HART service, is saying, okay, on this channel 16 I have whatever the respective name is to come through is what will show up here on the device name column. Okay, the expected is PT800-213. That's where I configured in my project side. That's what I'm expecting here, and sure enough, it did find PT800-213. Okay, so now I know I have the instrument tied to the right strategy. So now I can go ahead and assign and load the instrument to that control strategy. As you can see, it's loaded, server load complete, and then it's going to bring it onto my monitoring side where I can go ahead and configure the device to the system and start the loop test, which is pretty awesome. You'll see it here. And then there's a couple of ways. So there's a couple of things I want to show you in this video, but for the most part, it's going to be Asset Management, which is Field Device Manager with Experian's latest and greatest auto device commissioning functionality. So let's see here. I do have a trend here to my right, so we can view the test. And here to the left, I have the instrument that we're witnessing here on the camera. And I have developed two screens here to cycle at 3 seconds each. So every step, so from 0 to 25 to 50 to 75 to 100%, each one of those transition steps is 10 seconds. Okay, so we'll be able to see that 10-second step change in everything should match on the trend, everything should match on the face of the instrument, and then also on the dashboards. Okay, so you see now automatically the instrument has been added to my control execution environment, and then also it's been added to the UIO2 configuration properties. So what I'm going to do is hit configure. I'm happy with that. I want to go ahead and get that assigned to the channel and to my monitoring project side, and now I'm ready for the loop checks. So let's go ahead and do an automated loop check. Okay, so here it is here, automatic loop checking in progress. If you notice here on the corner of the instrument, you do not see a D, which stands for loop test enabled, which is a manual milliamp output that the instrument is producing. So it should show up here. It takes maybe 5 minutes or so for the loop check to truly begin. And you'll know when it starts when you see your control strategy activate. Okay, so if I hit refresh here. Okay, yeah, let me bring all this back. Okay, well, there we go. Oh, yeah, got too many windows open here. That should be good. So now we have not a number here, which is good. That means that the channel now has been activated. Let me bring up some new. Find a way to pin that. There we go. Okay, that should do it there. So about another 30 seconds or a minute or so, then we should see on the information column here to the most right, you should see that populate with loop check in progress, meaning that the service has instructed the instrument to send the 0 to 100% output to the DCS to do the 5-point test. And then here in a few more seconds, we should see this turn green. After it displays loop check in progress, this control strategy will turn green, and the loop check will start. All right, everything looks fine there. I'm not going to try to remove this for the sake of having too many windows open here. I don't want to disturb the camera. That's like here it is. So loop checking is in processing. Okay. So in a minute, or actually in a few seconds, this will turn green and the instrument will turn green and we'll start seeing data here on our data acquisition. There we go. We're activated. All right. So we should see a D show up here, meaning that the service has sent the 4 milliamps, the 25%, the 50%, the 100%. So, okay, there's the D. Okay. There's the 4 milliamps now that it's sending, a true 4. You see the zeros here. Okay, there's a 25%, and then also the trend will show that there's the 25%, or okay, 8 pounds. There's the 50%, 12 milliamps, 50%, so 10 pounds. Okay, there's a 75%, 16 milliamps. There's my 75%, 15 pounds. Okay, there's my nice little saw wave trend there. And there's my 20 milliamps. Okay, there's my trend on the PV trend on the instrument that's showing that truly indeed sent the milliamp output. And there he goes. So on completion of a successful loop check, the point should remain active. If there's any kind of, and I'll show you here what it means. Let's go ahead and end this test, and then I'll show you the actual test here that we ran. Let's upload the workbook. Ooh, that's not it. Open the workbook there. And let's see what we have. Okay. So test results, passed. Everything has passed here, 0, 25, 50, 75, 100, and here's the actual test. Okay, so here's the sequence of events here that has to happen for the test to work successfully. Here is where it sends the instruction to view the upper and lower range value, which in my case it's 0 to 20 pounds. All right, let me just maximize this. And here are the actual values. Okay, so there's 25, there's 50, 75, and 100. So that being said, this is what a successful loop check workbook should look like on completion of the auto device commissioning phase. Okay, and then once you're in here, I'm not going to save that. Once you're in here, you can go ahead and go into the properties. Well, let me just go to manager mode here. Okay, and then just if you need to go interrogate the instrument in a deeper form, you can hit maintenance view. But what you see here are the new SmartLine dashboards that we have embedded with 5.10 and better release of Experion. So that's going to give you a really nice primary variable, secondary variable description. As you can see here, it says gauge pressure. Secondary variable is meter body temperature, so it's really helpful there. But then you can open up the maintenance view display and interrogate the instrument a little further if need be. Okay. Here it's connected. You can see I am a planning engineer, so I can go into this instrument and make any kind of changes needed without any kind of further logging in. So this is it here. So let's go ahead and go in. Okay. If I do need to change the ranges here for whatever reason, you can just do it from right here. There's no need to go out to the instrument. Okay, you can remain on that engineering PC and make your changes. And then the cool feature too here is once you're done with the loop check, the engineer or the tech can write loop check 100%. I mean, there's no worrying about or wondering if the loop check was done. Now, if we look on the camera, there's our loop check. See that? There, loop check 100%. See where it says there, loop check 100%. We're back at 4 milliamps. Loop check 100%. And I apologize for the fuzziness here, but I am using a little camera that is not all that great when it comes to focus. But I still think it's pretty good. Loop check 100%. Okay. Then calibration, you can go in here and trim it up. Okay. If you're not where you need to be, you can trim that up. And then you can view all your process variables, your primary, your secondary, your tertiary, your analog output meters here. Okay. But as you can see, auto device commissioning coupled with FDM is huge cost saver. I mean, it is huge. I'm very excited to have this piece of software as one of our top tier offerings here for as a future shaping industry, this is where it's at. All right. So if during the auto device commissioning phase, if you do notice there's an issue, you can easily troubleshoot that issue, okay, from the engineering console without an issue. Diagnostics, okay, you can go in and do a deep dive of the instrument and view, real life analytical statistics of that instrument, the electronic side and the mechanical side. You can track the operating voltage, you can track temperature of the electronics temperature and the meter body temperature. There's so much you can do here. So basically what we did early on the auto device commissioning is with our service that runs in Experion, we initiated this trigger here, which is the 4 to 20 loop test. We did that automatically without a human being there. It's all fully automated, which is really, 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 really cool. You get detailed setup. Okay, so if during the commissioning phase, maybe you want to trim down your 21 or your high side, your 20 milliamps or my 20 pounds of pressure, trim it up with the Namur functionality. That can be done here. You have the meter body selections, which basically is an electronic spec sheet of the instrument. As you notice today, we used an analog output out of the display, and that's what I have here. That's how I configured this analog output trend and bar chart. Okay, I did that through this tool you see here, which makes it very easy. If for whatever reason you want to go ahead and do an audit, or better yet, some type of stocking part number, you can do that from right here. There's no need to go out to the instrument and pull that ID plate off or try to scribe it. You can just basically click that model number and the model populates here. Now you can take a snapshot of this or a snippet of this, and then you got your record there for your instrument. But all in all, ADC it's a really, really awesome tool. Again, I'm super excited and proud to have this as one of our software offerings. Coupled with FDM, it should make commissioning a breeze, never like before. All right, so I hope you enjoy this video. I appreciate it. I will be making more in the near future. Thank you.